So the focus of today's video is going to be reading a micrometer. Micrometers are able to measure precision parts to the nearest 1,000th of an inch. So we're talking about very, very advanced measurement here. Some micrometers can actually measure to the nearest 10,000th of an inch. We're not going to cover that in this video, but we will cover that in a future video down the road. What we have here is a standard set of micrometers. This set of micrometers will measure from 0 to 3 inches. Each individual micrometer has a range of 1 inch. So for example, we have a 0 to 1 inch micrometer, we have a 1 to 2 inch micrometer, and a 2 to 3 inch micrometer. If we wanted to measure something that was bigger than 3 inches, we would not be able to use this set. That's the downside to micrometers. They're very accurate, but they're also very specific. Vernier calipers, which we will discuss in a different video, are more flexible in terms of we can measure a much wider range of measurements. However, they are not quite as accurate as micrometers. So whenever we can use a micrometer, it is the most accurate form of measurement. If we wanted to measure something that was, for example, 4.05 inches, we would have to measure with a 4 to 5 inch micrometer. So the lower number in that range is what determines the number of whole inches in our measurement. And I'll show you an example of that in a minute. So for the purposes of this video, we're going to measure the diameter of this piston. Now it's important to note that pistons are not perfectly round. So when we measure the diameter of the piston, we don't want to measure in the direction that our pin goes across the piston. We actually want to measure opposite that. So if you are ever measuring a piston, such as in our activity, we want to make sure that we are measuring across the piston in this direction. We call that the thrust direction of the piston. So that's the direction we're going to be measuring across this part of the piston. Important thing to note. Now the first step in taking a measurement with a micrometer is we need to determine what range micrometer we're going to use for this measurement. Now I can tell just looking at this that a 0 to 1 inch micrometer is not going to get the job done. A 0 to 1 inch micrometer is way too small. Even if I open this up all the way, this measurement is not going to work with a 0 to 1 inch micrometer. I need something a little bit bigger. So what I'll do is I'll grab my 2 to 3 inch micrometer. So I'm going to take my 1 to 2 inch micrometer and I'm going to open it up to its widest range, which would be really 1.999 inches. And when I go out to 1.999 inches, I see it's still not quite wide enough to measure my piston. So that's not going to do the job either. So lastly, I'll step up to my 2 to 3 inch micrometer. So here's my 2 to 3 inch micrometer, and I can see that I can fit this micrometer if I open this. And again, we're opening this micrometer by turning what we call the thimble of the micrometer, just like turning a screw in or out. So if I turn this way, it opens it. If I turn this way, it closes it. So I'm going to go ahead and open this micrometer so it's wide enough so that I can easily slide this micrometer over my piston. Once I'm able to slide the micrometer over the piston, I'm ready to begin the process of taking my measurement. However, I've already started some of this process just by selecting the correct micrometer. Being that this is a 2 to 3 inch micrometer, I know that the number of whole inches of my measurement is going to be 2 inches. So I'm actually going to start by recording that. So I can go ahead and record that the number of whole inches of my measurement is 2.000 inches. Notice that we are always going in 3 decimal places. Why are we always going in 3 decimal places? It's because we are thinking in terms of thousandths of an inch. All of our measurements are in thousandths of an inch. Now, why does this third zero matter? If I was just to write the number 2, would that be the same measurement? The answer is yes. But it's all about accuracy. By including my 3 decimal places, I'm indicating an accuracy to the nearest thousandth of an inch. If I was to write this measurement by itself, 2.000, that would indicate a measurement of 2 inches to the nearest thousandth of an inch. If I just wrote the number 2, then that could indicate a measurement of anywhere, technically, from 2 inches to 2.5 inches, or depending on what I'm rounding to. So it's really important by showing those 3 decimal places, I'm indicating my accuracy to the thousandth of an inch. All of your measurements, if you're being asked to measure to the nearest thousandth of an inch, should be indicated in 3 decimal places just like this. However, I have not finished the measurement quite yet. So I'm going to go ahead and I'm going to take this a step further. And I want to now add in my 100 thousandths of an inch. And I'm going to show you how to do that right now. Now to measure my piston, what I need to do is I need to place my micrometer around my piston, and I want to go ahead and close my micrometer around the piston. Now this is a precision measurement tool, so I want to use kind of a light touch with this. I'm going to go ahead and I'm going to turn my micrometer in until it just barely makes contact with my piston. Once it makes contact with my piston, I can lock it in place by flipping this little switch. That will lock my measurement. Now I can move the micrometer around and read the measurement from the micrometer. Now remember, we measured to the number of hole inches just by looking at the range of the micrometer. But the next thing that we want to do is we want to read the number of hundred thousandths lines. Now the number of hundred thousandths lines is based on the number scale on the side of my micrometer. If we look at this number scale, we can see right now that we are reading a range of 0, 1, 2, 3, 4, 5, 6, and I see that the highest number that I see uncovered is my 600 thousandths line. So because the highest line uncovered is my 600 thousandths line, I'm going to go ahead and add that to my measurement. So the way we express 600 thousandths is we express this as a decimal point and then 600 thousandths, and it would look like this. What we are doing is we are basically creating an addition problem. And any micrometer reading we want to do in this manner. The next markings that we're going to look at are going to be my 25 thousandths lines. You will see that to the right of my 600 thousandths lines, I have 3 of these smaller lines uncovered. Each of these smaller lines represents 25 thousandths of an inch. The first one is 25 thousandths, the second one would be 50 thousandths, and then the third one would be equal to 75 thousandths. The next line, if it was uncovered, would be another 100 thousandths, which would put us at the 700 thousandths line, but obviously we are not there. But we can clearly see that we have a 25 thousandths, a 50 thousandths, and a 75 thousandths line uncovered. So we're going to go ahead and we're going to add that 75 thousandths to our measurement. So again, we're adding 75 thousandths, not 700 thousandths, 75 thousandths. So the way we need to indicate this is, again, at our decimal point, but we're going to put a 0 in front of it because it is 75. So 0.075. Again, we're continuing to build this math problem. This is all part of one measurement of our piston. The last part of our measurement that we need to read is from the thimble scale. These numbers around the thimble scale each represent 1/1000th of an inch. And if we notice, the number that lines up closest to our horizontal 0 line is the 10. So if we look at that 10, that indicates that we have an additional 10 thousandths of an inch to add to our measurement. Whatever number we read here is the last number that we're going to go ahead and add to that measurement. So in this case, it's 10 thousandths of an inch. So we'll go ahead and we'll add an additional 10 thousandths of an inch, or 0.010. Now again, those decimal places are important. If it was only 7 thousandths of an inch, we would put 2 zeros in front of it. We want to make sure that we pay close attention to place value. And we're going to go ahead and add these numbers together. And when we add them together, we end up with a measurement of 2.685 inches. In other words, 2 inches, 685 thousandths. And that would be the correct way to say this measurement. 2 inches, 685 thousandths. If we had a number, for example, that was something like this, we could simply say this measurement as 765 thousandths of an inch, or another way would be 0 inches, 765 thousandths. However you want to pronounce that is fine. So obviously this process is a little time consuming. It takes a little bit of time just to measure something as simple as a piston. But it's an important process in terms of being able to determine the condition of parts. When we tell a customer parts need to be replaced on their vehicle, They don't want to hear that it's just because we think they should probably replace the parts. We want to be able to give them some real data to tell them why those parts need to be replaced. Being able to tell them your brake pads are below the minimum thickness and therefore should be replaced is a much more objective way to tell them stuff needs to be replaced rather than, your parts just look like they need to be replaced. Some customers are fine with that. Some want to actually hear numbers. Your measurement of your brake pads is below specification and therefore it needs to be replaced. Much more accurate and much more consistent way to do that. By being able to use these measurement tools, you can be much more confident in your diagnosis of these parts, and your customers are going to be much more comfortable in what you're telling them they need to spend money on their vehicle. Thank you everybody for watching. Have a great day.